joined the BNSF Railway in March 2005 and has held positions of increasing responsibility within the mechanical engineering department there. As Assistant Director, he provides expertise and technical support to all business units of the BNSF regarding freight and tank car design, repair, and construction. His responsibilities include developing instructions for maintenance, repairs, modifications, performance, and construction of new rail cars, performing supplier quality audits, conducting specialty component testing and management of the BNSF program. Bruce has over 20 years experience with 13 at BNSF and 7 previously at railcar manufacturing and repair facilities. He holds a Bachelor of Science in Mechanical Engineering from the University of Texas. His credentials include EIT, American Welding Society, Certified Welding Inspector for 20 years. He's on the committee, and he's one of the major players in our industry for welding. He is also a member of AAR committees, the Tank Car Committee, also the Castings Committee, as well as the Fuel Tender Tag Task Force that we have working.
All right, good morning. I'll finish this session off. I just want to thank Mr. Kakovic and the Mechanical Association Railcar Technical Services for having me and putting on workshops like this. So if I were to summarize the first 2 presentations, John did a great job explaining the how-tos of welding documentation and the observations to consider when auditing the shop floor. And then Steve, you gave us a great MID view. You're the eyes and the ears for the railroad. And you provided us with some good fundamentals of the field manual and the common exceptions that you and your team are finding. I would be very surprised, Steve, but if any of those apply to BNSF equipment, you can talk to me after the presentation, okay?
We don't discriminate.
I know. All right. So I'll provide you a third perspective, and that's from the mechanical department of a freight railroad. So just a simple basic question, right? Why is welding important to the railroads? Well, a simple answer is we depend on safe and reliable rolling stock for us to move our freight and meet our customer expectations. So rolling stock, it encompasses both cars and locomotives. And I can't think of one piece of equipment manufactured in the last 50 years that does not incorporate welding into its construction. So this is a technical presentation, and it wouldn't be complete without a calculation, right? So a fun fact, I did some back-of-the-envelope math, and I estimated lineal feet of weld in a typical BNSF covered hopper. So for a 58-foot, 3-compartment, 286 gross rail load car, my rough number comes out to nearly 1,660 feet of weld joint. And if you consider multiple pass welds, I'd estimate close to 1,800 feet of actual weld metal deposited. Sounds like a lot, doesn't it?
Yep.
So I'm going to extrapolate that over 110 cars, and that equates to 37.5 miles of weld metal deposited in a single unit train, kind of like the one shown in the photo here. And I didn't give any weld credit to the locomotives. So I would say this is a quick exercise and is proof enough of why railroads depend on quality welds to move our freight safely. So my second question, welding from a railroad perspective, is who does all this welding? So starting with day one, obviously the OEMs, who are the car and locomotive builders and their suppliers. 2, it can be railroad and mechanical department employees such as carmen and boilermakers. And then certain railroads, they may also choose to use running repair agents who, in order to perform this welding, they must be signatory to the AAR interchange rules. And lastly, car owners, including railroads, we can have the option to send rolling stock to contracted shops for welding-related work. So what kind of welding is being performed? John hit on a lot of it. But what I mean by that is really just what are the processes being employed from the various whodunits in the previous slide. So manual welding, that's really synonymous with shielded metal arc process, or slang for stick. It's ideally suited for light repairs to be made out in the field, pretty much the railroad environment. So think mobile repair unit, or in the case of a railroad employee, we're talking about a mechanical road truck, would be outfitted with this process. The reason it's manual really relates to the consumable and the welder skills necessary to feed the electrode into the joint. So once the electrode's consumed, welding stops, and he's got to reload his holder with a new electrode for welding to continue. Semi-automatic processes. That's primarily used in manufacturing or back shop environments where arc shielding can be controlled. Gas metal arc, sometimes also known as MIG or hard wire, and flux core arc welding are the most commonly utilized, as they provide the high deposition rates from the semi-automatic nature of a continuous wire electrode feed. It's more production environment. We've got to get it in there. We've got to get it in there right and get it in there fast. That manual process is really for days gone by for manufacturing. Thirdly, automated processes. So that's commonly associated with sub-arc welding, where you got welding parameters preset, and the workpiece or the tip automatically moves with only oversight of a welding operator. So frequently used, this is frequently used in freight car center seals, as well as tank car tanks. I would point out that welders and welding operators may have different qualification requirements, or certification requirements, as John stated. A type of automated welding. In my travels, I have been seeing more and more robotic type welding making its way into our industry, which is very, very exciting. Railroading moves with technology sometimes at a very slow pace, and this is really some cutting edge stuff. I've seen it used successfully in reconditioning and manufacturing applications where there's consistency and repeatability in the part or the component being worked. So the fourth question of the day is, when is welding required from a railroad perspective? So back to my earlier statement about car construction. In the last 50 years, we've evolved from hot rivets and fully cast underframes to rolling structures of built-up weldments that by design can handle up to 1.25 million pounds of impact force and 3 million mile fatigue limits. That's pretty impressive. Welding is also necessary when certain components show signs of wear, such as freight car truck castings. Steve mentioned that. Certain field repairs are authorized on truck castings by the field manual. However, for the full reconditioning activity, these components are inspected and classified in accordance with M214. Welding can also be driven by regulatory inspection. If I go to the tank car world, stub seal type underframes on tank cars. Those welds attaching the stub seal to the tank car tank are required to be inspected every 500,000 miles or 10 years, whichever comes first. Most commonly what the shops see and report are fatigue cracks at weld terminations or higher stress areas, and those will require some attention by welding. Finally, making things right after a bad day. Shops that handle heavy repairs have a lot of welding in front of them when they're restoring wrecked equipment back to their original configuration. So where does this welding occur? RIP tracks, repair tracks, back shops. On being a Savlon, we operate 2 heavy back shops, one for car, one for locomotive, and we have over 50 field locations that may perform welding on rolling stock. OEMs, many of you here this week represent car and locomotive manufacturing facilities, and the component reconditioning shops, as we already touched on with freight car truck castings. Reconditioners are employing various welding technologies in their activities. And my last question in the morning, how is welding being controlled on rolling stock? So safety and reliability in welding starts with the governing code book. As John and Steve has already mentioned, the AWS D15 specification covers minimum requirements for welding on rolling stock, with the exception of tank car tanks. I'm in my 10th year on the committee, and we have a very diverse group that keeps us balanced in our technical discussions. I'd say if you're interested in more about that, please see me after the conference. Rule 82 in the field manual specifies use of D15 as a Rule 1 required publication. Additionally, Rule 82 provides us the details for car repair billing and the job codes specifically related to weld repairs. Some examples of technical specifications and standards. That includes M1001, design, fabrication, and construction of freight cars. We got M1002, specification for tank cars, which has appendices for tank car welding and NDT. And as previously mentioned, M214 is a great example for welding on truck castings. And when these technical specifications require a quality assurance program, the facility must implement an AAR QA system. So this system, it provides a framework of 24 elements necessary to execute the technical requirements of welding and other special processes, which further ensure safe and reliable rolling stock. And with that, I conclude my presentation.